Yo, yo, what's up? Today we're working on my custom operating system written in Rust for fun, I guess, by some metric. So what we have so far is we have like this like Rust kernel and it's booted by QEMU. If I run it, I see some stuff printed to standard out from QEMU, which is like the serial console from inside the OS rerouted into my terminal. If I look at what we have so far, we don't really do much of anything. This is kind of like more of like a proof of concept right now. And all we have is like, we have this allocator that we can run, or that we can initialize that allows us to have like vector and map types, stuff with like dynamic memory allocation, which should make the rest of the project easier. We have IO ports, so the CPU can talk to peripherals that aren't memory mapped through this like IO port mechanism, and these get like passed in to do things like serial output or talk to other IO modules like this QEMU provided thing that lets us shut down the OS by like talking to a port. We have unit testing, so if I run like cargo test, I see a bunch of tests from different modules that all get like run, etc. And we get like proper error recording if these fail, which allows us to run like our linter script on CI, etc., etc. And so then we're into our like, we have there's this concept, some like general initialization that needs to be done. Interrupts is where we're focusing today, and we have like a proof of concept interrupt handler that's run. So if we like execute an interrupt, that gets propagated up to the interrupt handler. The interrupt handler prints something, and we get that back over in main. And we have an RTC driver, so we can talk to the clock. And that's it, right? We're not really doing anything other than printing some stuff that we read from the system. Right? Like we can like set and get the date. That's about it. What I want to look at today is I want to look at a better interrupt handler registration. So right now, if I go look at the interrupt setup, there's this like static table in memory that like holds interrupt entries, I guess we'll call them. They have a real name, gate descriptors. Entry. And what happens is this is like 0, 1, 2, ... and then we get to like, I think it's 255 is the max. And what happens if somebody executes like int 2, the CPU will like stop what's happening and it will look at this entry, which is in static memory in our Rust executable. And it will like say, where do I go from here? What do I do? And this will have like a pointer to some code, and it will like ping over here. And when it's done, it'll go back to here where it was executing before. The problem is that right now, the only person who knows about this interrupt table is this like interrupt setup function. And it doesn't really make sense for all code that is running in interrupts to be written here, right? Because like if we wanted to say wait for an interrupt from the serial console in QEMU, which, right, like if I wanted to like type something in here, one way to continue from there is like you wait for an interrupt, and when you get the interrupt, you read from the buffer, and then you like do something with it later. It doesn't make sense for that code to live in the interrupt handler. It makes more sense for that to live in our how do you say this? In like the serial class, right? And so what we probably want is some way for like us to register handlers for different interrupt numbers with the generic interrupt table. And so what I'm thinking right now is if I take every single entry in the table, so this is like 0, 1, 2, 3, and I just point all of these to like the same function. And this function inside it like has a map that is more like Rust dynamic. Like I have like a map that I can register and remove things from. Then maybe this gets a little easier. The other reason to do this is because if any of these aren't registered, then when we execute an interrupt for those, we'll just crash. So I'm not really sure. Maybe it makes sense for me to store the mapping in here. Maybe. Maybe we'll play around with the code and see how that looks. But yeah, basically we need some way for like RTC driver to inject its own info in here. And ideally, we would want to be able to inject not just a function pointer, but like a function pointer that also contains some state, right? So like the RTC driver might have some internal structure that it needs to use. For example, like we might need to like use one of the ports that we've allocated. So we need some way to get data in here as well. So that's where we're gonna start here. And let's just kind of see where that takes us. So I haven't really thought about this too much. I thought I'd kind of just like start writing and see where it takes me. So I guess we need some sort of object that we can talk to or function that we can talk to that allows us to register with an interrupt. Probably, even if it ends up in like static memory, I'll probably still want to split out an object for this because it might make it easier for me to like track mentally. And it doesn't really matter. It's the same thing. So maybe let's call this a struct that is like interrupt handler. This handles the interrupt handlers. That's an awful name. We'll just call this interrupts maybe. And from the system's perspective, we'll say like interrupts, and we'll say like interrupts register handler. That seems pretty reasonable. Or maybe just interrupts register. So in here, we'll have a function register, and this takes a mutable reference to self probably, because it's going to need to like modify some internal state. And it will probably fail, maybe. And we probably also want to register like a number that we're going to be using. So let's call this num i32, or we'll int maybe. And this might want to return something, right? We might want to return like a handle to something that we can drop to unregister. But for now, let's just say that we've got it. And in here also, we probably want to pass in some sort of function, right? That takes no arguments. And is runnable. So now when the interrupt happens, we call this function. We might end up later wanting to pass in some context from the interrupt handler into these, but for now that's fine. So what we'll want to do is let's kind of stub out what this would look like. We'll make this public, and we'll make this public, and we'll make a new function that returns interrupts. And this just goes like this for now because there's nothing in here. So what this will look like is in main, we might say like let interrupts equals interrupts new. And or maybe we'll return this from interrupts in it. That makes more sense. So this guy will return interrupts. And maybe like a reference to him or something. I don't know. We'll figure it out. For now, we'll just do this. Because I'm just trying to like figure out what I want the API to look like before I do anything. So here, we'll say this. This is probably a problem because the names are colliding. So we'll call this like interrupt handlers or something. let's say for now that like our RTC service wants to register a handler. Or maybe we just want to register a handler directly. Yeah, let's do that. So we'll say interrupt handlers. What will we do? This will be mutable. And we'll say interrupt handlers register. And we'll register for, number like 55. And for now, we'll just say, we'll just want to like print something. It's just like, hello. Right? And if we execute that interrupt, what we'll want to see is that we don't crash, right? So what if I run this right now, which I should be able to, I should see something break here. Instead, I got something that says dropped log. Why is that? I expected this to crash, but instead I'm crashing in a different way. I don't really understand what's happening here. I don't understand how this is causing any difference in behavior. Is interrupt 55 handled in some way? Oh. It's maybe this. Panic. Right. Okay. There we go. So when we try to run this interrupt, what happens is that the system goes, wow, we don't have a handler for that. So then it calls this like double fault handler that I've registered at interrupt 8, I think is what it's called. Let's check the OS dev wiki real quick. Womp, 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 womp. OS dev wiki CPU exceptions is what I'm looking for. So, right, there are double faults. So a double fault occurs when an exception is unhandled or when an exception occurs while the CPU is trying to call an exception handler. So we're handling the unhandled case, and then we're calling the double fault handler, and the only thing that we're allowed to do is trigger a double fault and just crash. But we can like print some stuff first. While I'm here, I'm remembering that I'm not handling inputs to these functions correctly, so they actually give me some extra context. Here, these error code versions of interrupts, they require us to pop let's see. If this is my stack, I've got some like numbers in here that I'm using in like the context of like my function. Right, I'm like referencing this memory. When I hit like an interrupt, this jumps over to like my code over here. We'll call this like code. And he actually pushes an error code onto the top of the stack here. And so this guy has to pop the error code before coming back. Or else like now all of my pointers here are going to be off by 1. So like instead of 3, I'm going to get error, and 2, I'm going to get 3. So this is handled automatically, I believe, by the interrupt function I'm using. So here I've like annotated my function with x86 interrupt, and Clang or like LLVM is going to do a bunch of stuff for me in this case. This kind of maps to the Clang attribute interrupt, I believe. So if I look at Clang attribute interrupt, is it this one? Yeah, Clang supports the GNU style attribute interrupt attribute on x86 64 targets. It generates a function entry and exit. It uses iret instead of ret. Perfect. And all registers except for e-flags registered, which is stored by the iflag iret instruction, are preserved by the compiler. Any interruptible with stack switch code must be compiled with mno red zone because interrupt handlers touch the red zone. Sure, I don't know what that is. I don't think I'm using it. Nothing's caused problems yet, so we'll ignore it for now. But more importantly, the exception handler is very different to the interrupt handler with a different mandatory function signature. And the compiler pops the error code stack off the stack before the iRed function. So I think what we need to do is we first need to like get this interrupt frame type. Interrupt frame. And I think if we just repc without packing this, it'll be fine. And I think uword is probably u32. I think. And here we need to put this after and replace this with a comma. So we'll just do that for all of them. And then we should be able to, in my double fault handler, say I take in an interrupt frame by pointer. So frame is const interrupt frame. And then I get my error code, which is a U32, I believe. Error code U32. And so now let's just, for the hell of it, see if this looks sane. So we'll dereference the interrupt frame and the error code. And we'll look at the error code. Okay, we'll put some logs there. So we'll say frame is this. And we'll derive debug here so we can print it. And let's see if we see anything interesting here. No. And I don't know if that's for a good reason or not. So how can I check this? First, let's just do this. See if we still get the double fault. Good. And let's see if we print the error if we get anything interesting. Good. So it is the dereference of the frame here. So let's first print the frame and see if it's like a null pointer or something. And it's not. So maybe this does need to be repc packed. And let's see if we dereference the frame, if we crash again. We are not. Okay. So now the question is this a reasonable instruction pointer? We could actually check this. So I think if I run Python, I can convert this into something hex-like. So I can say I want this formatted as hex. So we can say I think it's like this, :x, format, and then paste this number in. Yep, okay, so we get this number. And then it would be cool to see if like this is in our main function, because that's where we executed our interrupt from. So it'd be cool to see this. So let's try to look at 17E8. 17E837. Okay, so this is not looking promising because none of this is in our code segment. But it's possible that the instruction pointer was previously pointing at the interrupt, which was not in the code segment. So let's try logging this on like a successful interrupt and see what that looks like. So we'll do this in this guy, right? Bump. Bump. And in main, we'll call interrupt 11 instead. We'll first, and we'll see what happens there. So cargo run. Shit. It doesn't like that. Invalid TSS type. Oh, that's new. So that's true. We've never set up the TSS, but I don't understand why it matters now. Because it didn't matter before. That's interesting. Also, this error looks wrong. Probably oh, I'm an idiot. This is not one that takes in an error code, so this is executing the wrong function type. So we'll try that again real quick. Because if I put that error code in at the end here, it's gonna think that I need to pop the error code from the stack, which is incorrect, and so then we're gonna get the wrong behavior. Right, so here we're back in the right spot, and let's see if this guy is something more sane. So format Python 3. We print as hex. Format in this number. And that's definitely not a reasonable instruction pointer. Assuming that the instruction pointer is supposed to point to like the code where I think it's supposed to. So let's double check what like a uword t is. Uword t. Uword t size 32-bit. 4 bytes, 32 bits. So that's correct. That should be a U32. And so what else are my theories for what's going on here? Let IP equals starFrame.ip, I think is how I get it out. Unsafe. And then I print IP. So I have to do this because I have my struct as packed, which is annoying, but it also might not need to be packed. We'll kind of figure this out as we go. Okay, so what do I get here? Same thing, and that seems out of range of code. What if I don't pack this? Misaligned pointer dereference? Yep, okay, so this should be that, and let's double check that this is what it should be. So this is an x86 interrupt rust. Tracking issue here is this guy. Okay, feature gate name. This feature will not be considered for stabilization without an RFC. x86 interrupt calling convention can be used for just finding interrupt handlers on 32 and 64-bit x86 targets. Compile uses blah, blah, blah. For more details, see the LLVM PR and proposal. So this is the same. And where is this guy defined? I think it's in the x64 crate, x86 64. Exception stack frame. Okay, let's see if we can. So I have this x86 64 crate checked out, which defines a lot of types. And let's see if this has exception stack frame in here. Okay, it's called interrupt stack frame now, so where is this guy defined? IDT interrupt stack frame. Okay. So this is IP. This is on x86 64, so it makes sense that these guys are 64-bit instead. And it does look like this is defined the same. It is repr-c instead of repr-c packed, which is interesting. And then let's see where this guy is used. So here he creates a frame, an interrupt of this type, interrupt stack frame, which is not a pointer. So maybe that's my problem, is that I should be doing this. And let's see if that prints something more reasonable. Frame 1184DA. That looks like a reasonable-ish number. So how can we check this? 1184DA. We look at objump again, and we look for 1184DA, and confirm that this is in fact in kernel main. So we know that with the instruction pointers approximately what we think, and we can tell that it's right before the call to interrupt register. So, which is perfectly correct. Let's go. Okay, sick. So now we've got the type right. We know that our interrupt handler we know that these are correct-ish. So let's go back here and we'll... So what confuses me here is if I go back to like the Clang thing, he says it takes it in by pointer. So I'm kind of surprised that when I take it in by pointer, I get a different result. So I wonder if Rust is doing some conversion under the hood. But either way, I'm not gonna like split hairs over it. It could also be that no, I don't have a good answer. But I'm not gonna worry too much about it. So I'm fairly confident this is correct. And now we can define our... How do I want to do this now? Now we should define some like generic handlers maybe, or figure out how to get the registration in. Let's do that. So when I call register, what do I expect to happen? I expect that in our interrupt table, interrupt 55 is going to... what am I trying to say here? This is going to be registered in the interrupt table. And so maybe what I want to do for now is I want like a nice error message when I call a wrong interrupt. Like right now, instead of seeing double fault, what I really want to say is interrupt 55 not registered. Right? So, because then at least I get like some useful info out of it. So that requires, I think, me to add an interrupt handler for every single entry in the table. I think. So that means that I need to find some way to generate an interrupt handler for every single one in the table. And what I really want is like 1 maps to like panic unhandled interrupt 1. 2 goes to panic unhandled interrupt 2, right? And so I could either generate this function for all of them, or I could have a function that I pass in something like this. Like I could for each interrupt handler maybe calculate my own offset. No, I was gonna say I could like figure out which segment I came from, but I don't think that that information's available to me unless it's CS flags SPSS. So what are all of these guys again? What did it say in here? These guys were named a little better. Instruction pointer? No, that's not helpful. Code segment? Not helpful. CPU flags? Not helpful. Stack pointer at the time of the interrupt? Nope. Stack segment descriptor at the time of the interrupt. So nothing in here tells me anything about which interrupt was like actually executed. Okay. But we could just generate a function for each one. That's maybe reasonable for now. Because if we were to then... Okay, sorry. Spiraling. So there's 2 things I need to handle here. I need to handle a generic function that might have like internal state associated with it, right? Like a lambda that basically gets converted into a struct and a function pointer, and the function pointer takes in the struct. That's like how these lambdas, or closures they're called in Rust, I think, should work. And I need to support like knowing which interrupt number I am. And so I think that this guy requires me to have, like, I don't think I can just shove that thing directly into the interrupt table. Because if I did, that the interrupt table only has a function pointer and not like data associated with it. And I can't like extract the data from this closure and put it somewhere else, like in static memory. So I think the appropriate thing to do here is to maybe in here have like functions or handlers, and this could be a hash map of the interrupt to a function. And really, it needs to be a dynamic function. Because I won't know which explicit type it is, and they are all going to be different. So that means this guy needs to handle this. So f has to be a function. I guess here it can just be anything. And here, oh, sorry, this doesn't need to be part of the type because here I can just do this. And we need to import the box type. So we have use core alloc. No, it's just alloc box probably. Yeah. And we need to import the hash map type, which is under hash brown hash map. Okay. So now we have a way to register functions. So now our registration should say self.handlers insert int f. Right? And we need to box this. And here we need to say handlers is nothing. Okay. So we've inserted this now, and now we are finding that this guy needs to be in static memory for our interrupt handlers to be able to access these handlers. So the other thing that gets interesting there is that we need some sort of synchronization to do this. I think we can leave this guy as is and say that like static like interrupt handlers is interrupts equals interrupts new. Sorry, interrupt guarded. So we need to make this guy like synchronized in some way. So we say interrupt guarded. And we need to use that synchronization primitive. So we have a utils interrupt guarded to say, hey, you're safe to use without getting fucked up by an interrupt. We need to create this guy. And then I assume he's going to be mad that this isn't const, but he's not yelling at me and I don't really understand why. So let's cargo check. There's probably some other bug happening. Missing field, aha, 166. Like this. Okay, so here we need to add a dash static on there. Or not dash, this. And now he's mad that interrupts new is a non-const function. So unfortunately, I think we need to wrap this in an option. Or yeah, I think we do. Because we can't initialize a hash map at compile time. So if we want this pub const function, this is going to get mad that hash map is not a const. So can we make const hash map new? Is there a way to create a const static empty hash map? Const gen. Ugh. So basically people are just saying no. So I wonder like what once cell and lazy cell are doing. First, a const is definitely not what you want. Const exists only during compilation. Oh, so when you use once cell, it like creates an initialization function and then runs that once, but that's not really what I want. It's definitely not what you want. Const only exists during compilation. A static would mean that you'd have some global mutable data. This is a big red flag for Rust. Shut up. I need global mutable data. Okay, yeah. So maybe what I'll do is I'll make this an option in here to make external usage more straightforward. And here we'll say we'll make an init function here. And we'll say self.handlers equals some default, right? This guy becomes none. And here we can say expect or as mute expect interrupts not initialized. And then we can insert. And now this guy should be in mute. Then here, somewhere, we need to initialize this guy. So probably here. So first of all, this should be a reference. And here we should say interrupt handlers dot init or lock init, like this. And then we return this guy, which means that this guy actually needs to be a reference to an interrupt guarded interrupts, which makes sense. We don't want to be like editing this guy while we're in an interrupt. So this is an okay API, I think. You could argue that the guard should be internal, right? To make this API a little cleaner. Right, like maybe it should look like this. And I think that's true. I think I do want it to look this. So we'll just have this like absolute shit show of a type here. Look at this. You love it when you see 4 angle brackets at once. You know that you're doing something wrong. But that's okay. So we do this. And interrupt guarded new none. Okay. And so now we have to get rid of this lock. And I think we're chilling. Oh, and now we remove these mutables from here because this is now a like completely this is legal, I guess is what I'm trying to say. Okay. So now everything is compiling as expected. And we have a way to register handlers. And now all we have to do is use these handlers from somewhere. So let's one time initialize the table to a common interrupt handling function. That interrupt handling function will check these. Let's call this interrupt handlers. I think I like that name better. Okay. And so that common function will point to this and check what's in there and call the appropriate closure or dynamic function, whatever you want to call it. So here we need 2 versions of that. One that that has error codes in it and one that doesn't. So we'll call this generic interrupt handler error code and generic interrupt handler. For now, this guy will just dispatch the other one. And also, for now, we actually don't need this. We just wanted to get the type right so that we could parse it, so that we could use it. Actually, I'm curious about the Rust calling conventions and how this guy gets in. We never figured that out, but we'll figure that out later. Okay, so now what does this guy do? He looks at the handlers. And I guess here he can just use them directly And he locks and he gets. Okay, so here, this is where it gets a little weird. Here, we need to know our interrupt number to do the lookup in the map. But, like, where the fuck do we get that number from? And you could actually say, you could do this. You say interrupt handler 1 says generic interrupt handler frame like this frame. You could just say that he passes in 1, right? And this guy takes in the interrupt number as an I32 or something. And then he can do the lookup. So he can say like, oh, I have these like global interrupt handlers that we've registered before, and I can look at those handlers. What is it? Lock as mute expect not interrupt handlers not initialized get. God, what a chain. So here he can say like let f is this. And then he can execute f depending on which number it is. So now all we have to do is figure out like what is this generic way of implementing this. Let me just quickly fix this like shit show of a function call. So we'll just do this and do this. He doesn't like that either. F has type option. Let me quickly check what it's complaining about. Why does F have an, oh, I see. Expect, and tier, we can say match to make sure that we have it. If it's some function, then we pass on the function. And if it's none, then we should panic saying that we haven't implemented this one yet. So we can say panic. Can you do like dynamic strings in here? Let's see. Interrupt not implemented. And we pass in the interrupt number. Or no handler. No handler for interrupt this. Cannot find macro because this requires allocation, so it's in the alloc crate. And I'm missing a string literal to format with. Am I high? What's it getting mad at? Okay. See a better output from cargo check. Oh. That's kind of nice. Panic just lets me do it like this. Neat. I didn't know about that. Okay, so that's new to me. So here again we pass in here again we would take in the frame and error, but this would be like interrupt handler like 8 for double fault. And he would pass in 8 like this, right? And so now there's probably some way to like macro this so that I don't have to implement every single one. Because each of these are the same, right? The only thing different is we're like hard coding a 1 in here. And I'm just trying to like picture how this gets laid out in code, in like the binary, and trying to think like, is there a way to inject this information more generically? And my gut says no. Somebody somewhere has to know that they're the interrupt handler registered with this interrupt vector, and they have to know to inject that number there. So we could do something like make a macro, and he is called like no error interrupt handler. And he basically just implements this guy, right? But we can say that like we have a number. So num is a identifier, I think. Maybe this can be like an expression because it's going to be like a 1. And here we need to use, there's this macro paste that allows me to like concatenate things together. I think the syntax is like this. Like I think I write a square bracket, angle bracket, then I put in my number, and then a square bracket, angle bracket like this. And let's see if this works. So we say no error interrupt handler, and we pass in 1 here. Paste is not in this scope, so I need to use it as paste, probably like this. Paste. Paste, paste. And here, it's complaining that interrupt handler 1 is already defined, which means that this is working as we expect. So I can delete this. And I really, really hope... I was going to say that they're like, can I automatically implement these? And I think the answer is no, because there's no like compile time for loops for me to like increment IDs as I loop. So please don't make fun of me, but I think I'm just going to copy paste this 255 times. So here I can just do this. So I've defined a Vim macro to copy this and paste it, and I can just say 254, run my Vim macro again. Oh no. What have I done? Hey Yoshi, what's up? You came in at a bad time. All this is the best code you've seen in your life. Right here. Yeah, I think, unfortunately, this is what my workflow looks like. Oh, boy. Okay, so I'm going to come back to this later, probably. But as far as I know, there's no better way to do this. But maybe there is like some sort of compile time loop I can use, or maybe that there's some way I could like define this in assembly and use some sort of compile time loop there. I think I saw something somewhere that was defined more concisely than this. But we'll figure that out later. Let's define the error version here, which is just the same thing, but with an error code here that the compiler knows it needs to pop off. So error E32. And we should probably prevent like compiler warnings by marking all of these as unused. And then we just have to go through and look through which exceptions here have an error code. So we have error code 8. So this should be error interrupt handler. 10, 11, 12, 13, 14. So that's these guys. 17, that's this guy. 21. And 29 and 30. Okay. And I think the rest of them don't. Jesus Christ. This makes me so sad looking at this. I'm 100% gonna come back to this later. So oddly, there is a previous definition. Oh, oops, I forgot 0. So what happens if I cargo check now? Interrupt handler 8 redefined. Oh, because I already made that one's defined manually somewhere. Okay. I shouldn't have included line breaks, that it's only one line. You're a genius. And now I'm trying to think like, do I really, really have to also do this again down here? Because somewhere I need to like set up these gate descriptors for all possible interrupts. And here I do have to like manually set an identifier. Oi, 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 that sucks. But we'll do it again, and we'll come back to it later. So let's say create gate descriptor, and this guy does the same thing, but instead of defining the functions, he's just using them. So down here, I have this like gate descriptor new, and then in here, I insert into the table with that function. So I can probably, let's copy this out into this guy. And here we'll just call this descriptor. This is all sane. We need to change the offset here. So this is where we start using these like fancy macro again, where we just say use this function, get my function pointer to it, and then inject this guy here. These guys will just leave all the same. These like attributes of the interrupt, we'll leave them all the same for now. And here we get the table, and we then insert this at num. And we'll call this insert gate descriptor number. Okay, so let's see if this works. So first, let's not do like the full shebang. We'll say insert gate descriptor 8. And what we hope to see is that when we call interrupt 8, we see the right thing. So he's mad because this isn't the right word. This now needs to come here. This doesn't have to be mutable. And, oh, we just have one more permissions thing. So this guy has to be declared as mutable so that he can call him as mute. But maybe this doesn't have to be as mute. Maybe this can be as ref, and we don't need it. Okay. So there's a lot of warnings here, but it does look like this is correct. So let's look at main, and let's see, when we call interrupt 8, we should see something interesting happen. We should see, well, let's see what we get and double check. So it says already borrowed, borrow mute errors. That's interesting. Who is already borrowed? It's probably this guy. That's interesting. Interesting. Borrow mute. I wish that I had like a backtrace somewhere to like narrow this down. I guess we could pop open the debugger again. So we could say QEMU wrapper and pass in this like -s args to like tell it to pop open the debugger. And now when I cargo run, this guy comes up and says the guess is not initialized, which is great. Now I can run GDB on my executable. I to like load the symbols from the kernel binary. So GDB kernel target kernel debug kernel. And I think I can break on panic, which isn't defined. So it's in main. There's a, I'll just say break on main rs102. And now I can connect to the QEMU thing, target, remote, localhost 1234. And when I continue now, fuck. I thought that it should break here and show me what this is. So why didn't that work? Why did that not work? Interesting. I guess we'll have, maybe we fall back on some more manual. Oi, oi, oi. Some manual bisection. So, this guy goes away, go away, go away. All of you guys, please go away. Okay, so cargo run. Oh, I have to fix the QEMU script to not try to wait for a debugger. And now nothing's printed, which is not helpful, but that also means that nothing broke. So let's see if it's in here. Okay, so it is something I added recently in this init function, and we can probably assume that it's... Aha! When I initialize the handlers, no, there's no borrowing in there. Okay, let's assume that it's this borrow here. And it is. It's probably this. And it is. So the question is, why is this a double borrow? Is it because this doesn't get dropped? That's stupid if it is. Waiting. That's so dumb. I guess the macro is like leaking scope. I thought that it didn't do that, but what you gonna do? Okay, so we go back to main and see if running interrupt 8 gives us something, and it does tell us no handler for interrupt 8, which is really good. That's really, really good. So that means that the piping of the interrupt table, this like shit show macro thing that's saying like, hey, run my generic interrupt handler with this number from the macro, that's all getting piped well. Hey, Oscar. And then we're getting here, we're like looking up the handlers in like the handler map, and it's complaining exactly how we expect it to. So that's great. And so now all I have to do is like register functions with this handler. So I guess we can just start doing this. Interrupt handlers, register. So we can like first, let's say for interrupt 8, what happens if we say like sup dudes? Okay, we got somewhere. The fact that it's spamming it is very concerning. That shouldn't be happening. Okay, so probably interrupt 8 is maybe supposed to be a no error interrupt handler. It does say that it has an error code, but it's also very clearly fucking up. So if I say that this is no error, it is not failing. So clearly what's happening is that like this thing that we ran into before, where if we like use this function signature with the error type passed in, it's supposed to pop that error from the stack before calling the instruction return. And it's clearly doing that and like fucking up. But like, why is that a problem? Because here it's saying that this handler for double fault. Oh, maybe it's because I'm calling it with like the interrupt instruction directly and not like when I call int, maybe that's just always using the no error variant because like the fault isn't being generated and so the error is not being put on the stack. That seems like pretty likely and reasonable. So maybe we'll just assume that this is okay for now. And we can check this. No, I have no way to check this actually. Let's check this with one of these other guys. Is there one that I can handle page fault. We could try... no, but I don't have any way to, like, generate page faults right now. Stack segment fault I can't generate right now. Basically, nothing... Since my kernel's so useless, I have no protection features enabled, so no faults are going to be generated. That's pretty funny. So I guess for now... Oh, alignment check. I can probably fuck that up somehow. By just trying to, like, dereference a bad pointer. So let's try that. That's number 17. So let's put this back to error. And let's get rid of all of these warnings. I think that I just type allow unused here. Temporarily. Now, let's see. So this guy is alignment check 17. So theoretically, let's see if we can just trigger that to happen. So I think if I just like take a pointer to an int. So I say like key equals const u32. And just make this like an unaligned pointer. So like 0x1233 as. And then I try to dereference this. I think that should trigger that alignment fault. Misaligned pointer dereference must be multiple of OX4, but that's not calling my interrupt. Look! An alignment check occurs when alignment checking is enabled and an aligned memory data reference. Alignment checking is only performed in CPL3. What the fuck is CPL3? CPL3. That's helpful. Canadian Premier League. Well, if we wanted to know about... What sport is this even? Soccer? What sport is this? Ottawa's playing Halifax. Highlights. Maybe the highlights will tell me what sport. This is such a... Yes, soccer? Yeah, look at that. I guessed right. Yeah. Okay, so that's not what I wanted, though. But if we wanted to... Now we know if we Google CPL3, we will get some soccer stuff. OS dev? You want me to look at the scores? What do you want to know? What, like, is this for your fantasy league, Yosh? Oh, you can look at the scores and see that since it's 1-0, you know it's soccer. Yeah, you're right. Okay. x86, I think is what we were trying to look at. Protection ring. Oh, I see. So since we're not in, like, the shitty protection mode, like the user space one, probably. So they're calling CPL and rings the same thing. So I only get the trap in user space. Who designed the protection ring? Who knows? Intel, probably? Is there... Maybe it could be from, like, even before. Oh, god damn it. Stupid Apex joke again. No! No. Okay. Okay, what was I doing? I was trying to prove to myself that this error variant of the interrupts was necessary and correct. But I have no real way to prove that because I think when I go through all of these exceptions, I think I can't trigger a single one of these. So we'll just hope for the best. And call it, we'll just keep going. So I guess what we'll just start doing is we do the same shit here where we inject an entry into the table for every single one of these. So we vim macro it up again, copy, paste, increment, and then we do that 250. Oh god, what just happened? We do that 254 times, so 254 Wait for it a little bit. Wait for it. Let him go. And then we come back later and hope to God that there's a better way to do this. But for now, this is where we're at. Okay, so we've added an interrupt allocation and registration system. We've proven that we can like register a function that is called here. So if we just say like register 8, we've proven that that does in fact say, let's fix my main function so that it's not performing invalid memory accesses. We have proven, no handler for interrupt 13. Hold on. When am I triggering interrupt 13? So I was going to say that we're ready to go, but it does seem like that's not the case. So why the fuck not? No handler for interrupt 13. So why is interrupt handler 13 happening at all? Double checking my macro. So this guy creates a new descriptor and he inserts on the table, blah, blah, blah. He takes in this number and he inserts into the table at that number. Why is interrupt 13 being called at all? What is 13 again? Let's first run this. 13 is general protection fault. Who's calling this? Oh, maybe I am just fucking up. That'd be cool. I wonder if I'm like overflowing my stack or something, and that's causing something. Very well could be it. And oh, because I'm trying to yeah, I can trigger that because I have my global script table set up. Wait. Let's go back. We can prove this. We can prove the error code thing. So first of all, if we nuke all of these, first of all, does this run? Yes. He's still getting mad that there isn't a handler for 13, so let's see what happens if I write something in 13. He gets mad about a dropped log. I don't understand why. We're back in this state where we're spamming. And is someone calling did I write interrupt 13 somewhere? Why is this happening? I don't understand why interrupt 8 is going to interrupt 13. I've missed something. Wait, why isn't this crashing anymore? Why? Oh, right. Okay, so calling interrupt 13 directly is not valid with our current understanding. So calling interrupt 8 should be, but it's still doing the same shit. What am I missing? Is it because I haven't registered a handler here and it's like fucking up in some way? Okay, that's what I expect. So how was I in this broken state before? I don't really understand what happened. No handler for interrupt 13 is still actually being called. Is there someone typing like int 13? There's like a... I must be writing to some invalid memory somewhere. But I can't imagine where that's coming from. Is it here? Invalid TSS type? Oh, fuck, I'm doing it again. It's because God damn it. It's because I'm not allowed to call interrupt date. This needs to be like 55 or something. Oi, oi, oi. Okay, sorry. I think that everything's actually working as expected. And I just forgot how expected works. I am still getting... hold on. Hold on. Okay. Something... I've definitely fucked something up. And I don't know what. So let's look at my diff, see what the hell I've done. I've added these, like, interrupt handlers. And clearly these, like, error variants are causing problems. So I guess... Well, I shouldn't say clearly, but that's the current thought. So let's just put no's back in front of these. And maybe, like, the Rust compiler is handling these for me, even though... no. Even though it says it shouldn't, so... I don't even know, like, where the problem is happening. Is it here when I, like, create the interrupt? Okay, so that's related. Oh my god, I'm doing it again. I'm just, like, forgetting stuff. Okay, so I think what happened is I call interrupt 55, but I don't have a handler for 55, so it's crashing. Then it's trying to call 13, and I don't have a handler for 13 either, so it's crashing. So I just need to go back to, like, registering all these. God damn it. What did I call that register function? It was insert gate descriptor. Insert gate descriptor. 0. And we write that ugly vim macro again. And let's only do like 20 of them right now, just to see. I was worried about like that protection fault I was hitting before. And so I just want to make sure that this is all good before I start doing everything. Okay, so that's working, right? I've inserted not all of them, and we're getting like logs that are saying that I logged something from a handler, so that's good. So let's just do like 220 more of these. Wah, 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 wah. God, it's so slow. And then 10 more, I guess. 4 more. There we go. And does this still work? Everything's working as expected. So I just like went down this rabbit hole. I think I just mistyped something somewhere, forgot to insert a call, and bounced around mistakenly. But okay, so I think we're good. We have these interrupt handlers set up. In main, we register an external function with interrupt 55. When we call interrupt 55, it's jumping into that spot, and we get the logout. Solid. Jesus, what a roundabout way to get here. So I guess let's do a quick like stop here to satisfy the linter. To make sure that like we can like commit this as like a nice little intermediate thing. So here we need to add all of this stuff back. We'll call this hello from interrupt 55 as example code. And now the only thing is that he's mad about that type complex type, and I'll just say, shut the fuck up, linter. I don't care. You don't tell me that my type's too complex, even though I also think this type is too complex. I still want you to shut up. And all my tests still pass. Okay, good. So we can say this is a initial implementation of interrupt handler registration. And I'll fill in more info there later. And now we're chilling. So now the question is, how do I like write a driver that will work with this correctly? And so I think I have a couple options here. I have the RTC driver hooked up and a serial driver hooked up. And I think the RTC driver triggers an interrupt every period of time. triggering IRQ8. So let's see what happens if I just run this in the RTC driver. So read the current value of register B. So here, to enable interrupts from the RTC, I just say take register B. Oh, fucking disable NMI shit again. Read the current value of register B, set the index again, and write the previous value ordered to 0x40. So this is the part that turns it on. Okay. So let's just copy paste this over here somewhere, and on RTC initialization, let's just run it. So this is the CMOS NMI control port. We write a byte here to this, and CMOS, oopsies. Then we say from the data port, we read a byte, read a byte. So that's this line. Then here we do this again. And then here we just write, this is to the data port. We write prev and 0x40. And now if I run this, nothing bad happens. But maybe because I've masked interrupts. So let's go back to this like interrupt code. So these are presumably coming through the PIC, I think is what it's called, IRQ8. So I think that here, probably let's just disable the disabling. Oh, very nice. Very nice. No handler for interrupt date. That's exactly what we expected to see there. And if I go back to the RTC and I turn all this off, I still have no handler for interrupt date. So that's not what I expected. But I guess that's probably because maybe it's like on by default. I also didn't disable and enable interrupts there, so maybe that's related. So let's create a guard here to disable interrupts. Let interrupt guard is this, and this just guards nothing, but we still want the interrupts disabled, so we say you kind of pretend that we're like locking some resource behind an interrupt lock, and then just dropping it here. So this is like a kind of like dirty way for me to make sure that I'm like disabling interrupts in a way that's consistent with the interrupt handling elsewhere in the code. Okay, so now if I go back to interrupts and I mask these again, no handler for interrupt 8. I guess it's hard to prove that this is right. But I guess what we can do right now is we can like remap the PIC. So the problem is that this like IRQ8, but IRQ8 is shared with it's shared with this double fault thing. And so I don't know if the interrupt I'm getting is from the RTC or from like the CPU itself. And so what you're supposed to do is you're supposed to say like, hey, this like external interrupt handler, let's pull out some drawing paper. So we have like the CPU, and it has like a interrupt lines going to this like maybe interrupt line, probably not sure. We'll say that this is a bus or a wire. This goes to like this like PIC, which connects to the RTC. So this is what I'm like expecting to generate interrupts on a timer. This goes over here, and he says like, oh, this is plugged into port 8. CPU, I've got interrupt 8. And the CPU is like, yeah, sure, interrupt 8. But the problem is that like the CPU also has like internal interrupts. So what this guy's supposed to do is he's supposed to say like, I got an 8, but like let's just like add 20 to the input. And then I'll say like, hey CPU, I got interrupt 28, not 8. And so there's just like a couple like IO things I have to do to configure this guy. And also, so when I'm like writing, like commenting out this code here, this like 0xFF that I'm writing to the picks, there's actually 2 of these in series. Pick 2. What I'm doing here is I'm saying like, hey, if you see this interrupt here, just like fucking ignore it. Don't worry, we don't need it. So that's what these like masks are doing, and that's why when I like comment this out, I start seeing problems, and when I don't comment them out, it's fine. Okay, so we went over this previously, this like pick remapping stuff, and we actually got it into a point that worked. But then I deleted it for some reason. And I don't really remember why. But here is like the way you remap the offsets here. So we can do some sanity checks here, where we see if we remap these picks, then how do I say this? Then we should see a different number than 8 causing problems. And then we can know that this is in fact the RTC yelling at us. So let's just convert this into some Rust code, pick remap. This offset 1 is a I32, offset 2 is an I32. This also needs to use these picks, or these like ports, I guess. So this is data and command. So this is command, which is at port 20, and pick2 command is at A0, if I remember correctly. Hopefully I do, because if I don't check and this bites me, I'm going to be mad later. And then here we just take in the ports. So pick1 command, pick1 data. Jesus, so much typing. Pick2 command, pick2 data. Okay, so now we have everything in here that we need. So this is now these to be let. So I'm like grabbing something from the pick. So this is pick1 data. So I just say pick1 data dot read b, or get b. Is it not read b? I thought it was. Why is that not? Whatever. I thought that should autocomplete, but it's not. Whatever. Pick2 data read b. So some semicolons here. Pick1 command write b, and then this guy. The weights, we don't need IO weights because these are handled automatically for us by our write functions. And then here, I wonder if we can do something like a little cheeky, like lowercase all of these, and then do a little quick little cheeky vim macro to say write b. Yeah, look at that. I love it when stuff works right. And now I just need to define these constants, so we can just yoink these guys out. Drop them in here. Say that these are all, so how do I say this? Const this is a U8 that's this, and we delete all the trailing shit, and we just there we go. And then we add a semicolon to all these. Okay. And this actually might just run as is. So let's just see. This is called pick remap. And it's offset 1. We're going to say like 30 and 38 or something, because I think there's 8 IRQs per pick, and then we pass in all of the things it needs. So pick1 command, pick1 data, pick2 command, and pick2 data. And so now, if if I understand correctly. Hopefully we don't see it yelling about, oh, well, first we actually need to prevent it from failing to compile. So let's get the compilation working. And offsets, we'll make these U8s for now. Ooh. Okay, so when I run this, before we were getting no handler for interrupt 8, and now we're getting no handler for interrupt 48, which is like a really, really good sign that these like pick remappings are working. Okay, so let's just clean this up a little bit. Just a smidgen. So here, why is this like this? Okay, here. And this, let's just like align these a little better. What's happening here? Okay. Probably tabs in there. Blech. Okay. So now, I guess, for now, let's just assume that this 30 and 38 are, or I should say hex 30 and hex 38. So where did I write that? Let's remap the first one by 33, I think. So 0 gets a 33 to avoid the 32 in CPU interrupts. And then this one should be 41, because this is this plus 8. And let's just, for now, assume that these are, like, constants, right? So, like, the rest of the system will know that these are the IRQ mappings. Really, in reality, like, you could make this registration function take in instead of an int. This could take in, like, an IRQ ID, right? You could say, like, enum IRQ ID, and then you could say internal I32, and pick 1 I32, and pick 2 I32. And then externally you wouldn't need to know. And now that I've written this, and I was just trying to justify that you could do this and you shouldn't, that I'm not going to bother, it's like really, really, really hard for me to justify not doing this now. So I'm just going to do this here. So my registration function is now, instead of going to take in here, it's going to take in like interrupt num, and it's going to take in this IRQ ID. And then here, instead of inserting this, we're going to say, we're going to take the number, interrupt number is match IRQ ID. And if it's an internal, so IRQ ID internal, we just map it directly. If it's IRQ ID pick 1, we say I plus pick 1 offset. And if it's pick 2, we do the same thing, but with pick 2 offset. And then we just need to define these as constants. So we say const pick 1 offset is 33, I think I said, and pick 2 offset is 41. And then I replace this with pick 1 offset and pick 2 offset. Okay. Now this almost compiles, except here, now we need to register for IRQ ID internal 55, I think. And this is interrupts. And probably IRQ ID needs to be public. And these guys need to be typed. And what doesn't it like? Right, because this guy is not the right name, so interrupt num now is what he's named. And what doesn't he like now? Expected U8 found I32. Yeah, okay, so these guys can be U8s. And these guys can also be U8s because they can't go above 255. And I guess that means that this guy can also be a U8. And what doesn't it like now? Borrow I32 is not implemented for U8. Oh, oops, this is the wrong word. It should be interrupt num here. And wait, what is that like? 432 get required for I32. Borrow I32 is not implemented for U8. Shouldn't this be a U8? Why am I having problems here? Interrupt num. Oh. Oops. Oopsies, oopsies, oopsies. There we go. And then the last part is at 375. This guy expects I32. I'll just make him I8 or U8 now. And that means that 368, this guy isn't a valid number. There we go. Okay. So now we say allow unused to appease the linker. Cargo check. Cargo format. We run the lint script. Everything's good, so we commit this as a checkpoint at IRQ remapping. Okay. So now we are only getting the interrupt from the RTC at a number that is reasonable. So if we run this again, let's double check. So this is an interrupt 32, which is IRQ 8, I guess. Is that right? So this guy says IRQ 8. Let's look at the picks again. Each pick has how many on them? 16, I think. Yeah. So this should be IRQ 18. So let's check that. So if I say I want to register a handler from this, pick 1, I should say, number 8. He doesn't like that. No interrupt for interrupt 32. Double checking, double checking. So let's try internal writing 32 directly. He doesn't like that. Why not? Why not? Why not? Why not? Okay, let's disable these external interrupts again to make sure that that 32 is the one I expect. Yeah, so that 32 is in fact coming from the pick. And what is it? I'm confused. I'm confused. So pick 1 offset is 33. So the fact that I'm getting one from 32 means that this must be one of the like internal exceptions. So CPU exceptions. I thought that this was in here. OS dev CPU exceptions. Oh, it's just called exceptions. So 32 doesn't exist. Let's change these offsets and just make sure that I'm not like making a mistake here. So 33, we'll make this like 35. No handler for 32. So no matter what, it's still mad. But if I mask these, interesting. But when I did like this before, it was working like I expected. So maybe let's just, for the sake of it, make these bigger. Okay, that makes more sense. So is 64 hex 40? It must be, right? So we'll say format in hex the number 60 in 3C. Oh, 64, sorry. 40, yep. Okay, so if IRQ 0 is triggering. So I guess now let's only unmask the things on the pick that we care about, which I think should be this. If we want interrupt 8, if I understand this correctly, then disabling the 8th bit. Oh, sorry. This? 1, 2, 3, 4, 5, 6, 7, 8. This should maybe give me what I want. Let's see. Cargo run. Nothing. Nada. I guess I actually have to read how to unmask these. So, pick. Programming the pick. Initialization masking. Here we go. So here, the pick has an internal register called the IMR, or the interrupt mask register. It is 8 bits wide. The register is a bit map with the requested lines going to the pick. When a bit is set, the pick ignores the request and continues into normal operation. Note that setting the mask on a higher request line will not affect the lower line. Masking IR2 will cause the slave pick to stop raising IRQs. Here's an example of how to mask an IRQ. Yeah, so you just take the input, and then you... Yeah, okay, so that's reasonable. So, if I do this, I get no handler for 64. Here I get no handler for interrupt 80. That's the one I wanted. And so, that's not the one I wanted. We'll do this. So now I'm getting interrupt 8. So I would think that RQ8. Oh, is RQ8 the first one of this guy? So that's 0B1111 1110, and this should be fully masked. Because RQ 0 to 7 is the one on the first one, if each one has 8. So why am I not getting these? Did I enable the interrupts? Yeah. I am missing something. I need to figure out where this line, how to get the RTC. I guess the other one I could try. So first of all, let's not exit here. Right, and then we should see, we have like more time to find if the interrupt is getting hit. And let's see, let's try the console one. So this is serial. So somewhere they should say that there's like an RQ here. OSDev RQs x86. Interrupts. Here we go. So interrupt 8 is the CMOS real-time clock, right? So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah, okay. So here it should be the first one on number 2 is the one that we want. Aha! Okay, I see what the problem was. So before, when I unmasked, oh, maybe this is backwards. Sorry, I thought I understood it, but I don't. I do not. So I thought that if I say pick 2, 0, I should get hello from interrupt 8. Oh, here I've masked all from interrupt from the second one. So this just needs to be 1111 11011, I think, to say IRQ2 on this guy is the cascade one, which means that interrupts from this guy won't show up unless that's unmasked. So let's try that. Hello from interrupt 8. Let's go. Okay. So, or I should say interrupt 0. Yeah, okay. So we are in fact getting there, and now we're getting interrupts from the RTC. That's really sick. So we've initialized the pick properly. We'll just put this in quotes for now. We haven't really really when we register, that's when we should be unmasking these things. But for now, we'll just leave it in raw in it. So that's this guy here. And let's prove system with a serial RTC driven interrupt. So now let's see, I think probably when we like receive an interrupt from the RTC, we probably have to like acknowledge it so that we don't interrupt it again. It is important to know that the status registry will contain a bit mask of telling which interrupt happened. The RTC is capable of producing a periodic interrupt, an update, interrupt, an alarm. If you're using the RTC as a simple timer, what's important is that if registry is not read after RIQ8, the interrupt will not happen again. This is exactly what I was looking for. So let's say we'll make a loop. We'll just say RTC loop here. We'll say logger service and RTC service, which is a shitty loop, I know, but for now we'll make it work. Well, that's just what we're gonna do. And here we'll have a service function that just clears, that just reads that register. So we say self dots. We'll say read CMOS reg, and this is on the control port. So self CMOS NMI control port, and then we need to pass the data port too. So passing that as mutable, self data port, was it CMOS data port, and NMI enable. And what do we need to get here? We need to read register C. So just clear the interrupts all the time and see what happens. So probably this is supposed to be done from within the interrupt itself, right? Because like we're just kind of saying like unconditionally, hey, we've handled this interrupt from main, even if we haven't. But I just want to see that we do in fact start seeing this like pile up. And we're not, which is kind of confusing to me. So this is, what is it? If register C is not read after an RQ8, it will not happen again. So even if you do not care about what the type of interrupt is, just attach this code to the bottom of your RQ handler to get another interrupt. So this is 7.0, and so this is 7.1, which means that this should work, this read CMOS rig. Maybe I have to like actually set up the frequency. Changing the output divider changes the interrupt rate without interfering with the RTC's ability to keep proper time. The lower 4 bits of register A is the divider value. The default is 0, 1, 1, B, or 6. The setting must be a value from 1 to 15, a value of 0 to disable this interrupt to calculate a new frequency. So what's 0, 1, 1, B? That's this frequency shifted by rate -1. So here, I probably just want the rate to be 1 for maximum interrupt frequency, which means that I can say on initialization, I can say prev a val is read CMOS reg, the control port, the data port, and we always have to re-enable NMI, of course. And here we read from register A, and then what is this 0x8A? Reset index to A. So he writes, why 0x8A? That's, oh, sorry, it's not 0x0A, it's 0x8A. Oh, shit. So why is register C OC, but A is 8A? Where's the datasheet for this thing? Fuck this. Like, is it this guy? No. Where's like, I just want like the datasheet of this. Oi, oi, oi. Okay, well, let's just trust it for now. So this is 8A, 8A. And here I want to write. So write CMOS reg. And I want to write in the previous value. Here, this guy. This is all I want to write. So the previous value and 0xO and or 1. So the rate, I just want this to be 1 for maximum interrupt frequency. And this is prev a val. Okay. What doesn't this like now? He does not like that this is not a U8. Oh. Like this. Okay. So now, do I start to see the interrupts again? I only see it once. I want to see this like many times. Let's make sure that this is running at all. So print line hello. That sure is. So I'm clearing that register over and over again, like it says. Right? I'm reading port 0xOC and it's not doing anything. Let's just try 8C for funsies. Yeah, I don't get it. I don't get it. But we're close. We are close. So maybe I need to act it on the pick as well. The pick chip has 2 interrupt status registers. The ISR tells us which interrupts are being serviced, meaning IRQ sent to CPU. The IR tells us which interrupts have been raised. It can be read via this command. So note that these functions will show bit 2. Perhaps the most common command issued to the pick chips is end of interrupt command. This is issued to the pick chips at the end of an IRQ-based interrupt routine. If the IRQ came from the master pick, it is sufficient to issue the command to only the master. So what is that for? I'm assuming that means like, hey, we've done this, so you can register, like, you can keep going. Yeah, let's just assume that this is necessary. Which means that in my interrupt, let's see. How do I want to do this? Let's for now just for now, we will bypass some of our like protections of like duplicate ports and port conflicting and stuff. We'll get these ports here. So this is pick2 command, which is 00A0. Like this. And here we'll say pick2 command write. Here we'll expect this should work. And then in here we will write pick EOI, which is 0x20. And hopefully this will let me get the next interrupt. No. No luck. No dice. Okay. Well, I'm definitely missing something. But we got pretty far today. We got to the point where we can like register interrupt handlers with this interrupt module. And that's pretty good. So we have some things to clean up. How we did this was we like made this like static map that we can register with. And then for each interrupt number in the interrupt vector, we like insert a function that says like, hey, I am interrupt number here, look me up in the map, basically. And that's working, but this is like pretty ugly here, how this is handled. We just like manually enumerated every single interrupt number. I'd like to fix that up a little bit. And then we like initialize the external interrupts a little bit and are struggling with getting a second iteration of those interrupts occurring. So I think I'm going to do some off-screen reading because I'm not close enough that I feel like bumbling around on stream is going to result in anything interesting happening. Oh, wait, hold on. I just noticed something missing. Let me try one more time after all of that. Yeah, okay. Still broken. Woo! Yeah, so I don't think there's bumbling around here is going to result in like anything interesting. So I'm going to do some off-screen reading and then try to pick this up tomorrow. Thanks for watching. If you want to see more, you can catch me tomorrow at 2 PST or catch up on YouTube. Thanks for watching. See you on the next one. Bye.